Let us start and do some question practice. So first example is explain what is the fundamental theorem. Before going to the SCF and HCF LCM part, it was a very common and very easy question, and it for best for the exam related. Okay. Question is, consider a number 4 to the power n where n is a natural number. So we want to check there is any value of n, that is for which this is the individual digit 0. This part is important and this part is also important. This says that, for example, if I have a to the power n, so the question says that I want to check the n's of any value of n which n belong to the natural bit, which n, like in n, this is the for 11, but for you it says that n is a natural number. Okay, n is a natural number. So like 1 2 3, so a to for n natural number, the for example a to the power n, the any value of n, for example say n is equal to a, n is equal to the x, it is any number. For this, the a to the power x is equal to the unit digit is 0. Okay, this was the answer. For example, this value is 10, so the unit digit is 0. This is the question. For that is the question is like the 4 to the power n, since n is the natural number, so we want to check in the natural numbers any number of a, any number of n which for which the value of 4 to the power n is equal to the unit digit is 0, irrespective of the value of the remaining digits. My main mission is to find the 0 in the unit digit. Okay, so how we solve? First of all, how we obtain a unit digit? Can you think about it? Like if I say that hey you, I say you that is this is the unit digit, so how you obtain? For example, I say that this is the 10, so for the 10 the unit place is 0. Similarly for 100 the unit place also 0, and similarly any number for which the unit place is 0. How we obtain the unit place? I don't know. Let's solve it. First we factorize this theorem. Okay, let's first factorize. For 10 the factor is similarly the same concept, 2 5 5 1, it is 2 into 5. For 100 again but tricky, 250, 225 and 5 square 1. Okay, this is 2 to the power and 5 to the power 2. Okay, and if I say for 20, just imagine, no, I say let for 1000. Okay, like 1 2 3 2 5. Okay, then 2 to 50, then 2 for 125. I think that was good because 0.5. Yeah, and for this is 5 25, I say 5 square, so basically 2 cube into 5 cube. Okay, for 20 is say 2 5 and 5 1, say 2 1 into 5 to the power 1. Okay, so whenever the unit place is 0, the whole factor is in the form of 2 into 5, like 2 to the power 1, 5 to the power 1, 2 to the power 2, 5 to the power 2, 2 to the power 3, 5 to the power 3, and similarly for 1 1. My mistake. Yeah, 2 to the power 2, 5 to the power 1. Okay, so this was the, you see, like any factor has which has unit place 0, the factorization. So the conclusion is, what is the conclusion? So my conclusion for the overall scenario, it is, if a to the power n for any n is a natural number, okay, any n is the natural number, the a to the power n is equal to unit place 0 or unit digit 0 has the factorization of 2 to the power n into 5 to the power n. You see in the examples, okay, you see in the examples. So now this is our question. The question says that consider the number of 4 to the power n. So we want any number can end with digit 0 has have any number. So 4 to the power n, okay, when we factorize this theorem, okay, when we factorize, it should be in the factor of 2 to the power n, 5 to the power n. So this implies 4 to the power n can be written as to the factor which is 2 to the power 2 to the power n by the quotient rule, or simply the exponential rule. We know the a to the power m into the n, it is a to the power m into n. Remember it. For more we will discuss in further. So it is 2 to the power 2n. Okay, so we see that here the 5 to the power n part is missing. Like we can say that the 5 to the power part is missing. So by our conclusion, we say that 4 to the power n for any natural number, for any is, and where for any n is natural number can't be end with 0 in its unit digit. Okay, its unit digit. It was the overall answer. So we can say that 4 to the power n can be written as 2 to the power n into 5 to the power 0, because another rule, any number whose power is 0 become 1. Remember it. So it is the whole concept. Since it was not written in the form of this, you can say not because the 0 is the not power, where n is the natural number, so 0 is not a natural number, so that's why this form is incorrect. Okay, so we can say that since 4 to the power n is not in the form of we can say that not in the form of 5 to the power n, so this implies this is not be written in the form of unit digit. This was the exam answer. Overall this question is not very hard, but for the concept I hope you understand, and I give you some questions if you understand it once again. Okay, so I think you understand the concept of this question. My today's task is like I want to explain the SCF and LCM's rule, but for the time lap this will held in next class. So I hope you understand the concept. Main part is the understanding the concept, but for SCF and LCM we'll discuss next classes. Okay, the overall meaning that the highest common and least common factors. Okay, this is our HW part for you. If you understand it, question number 1, sorry for question number 1, try for 6 to the power n. Let's see what happened this. Okay, h w, okay, and okay, this is good. And if you understand the concept, you can see that with your on question, this series will coming soon as we move ahead. Okay, like at the end of the chapter, at the end of every chapter or concept. Okay, main part is this, and if you understand this concept, you can build your own question. For this question related, like if you understand the question, can you think like a new question, can you generate it? If you generate it, that's a good point, and solve it. Okay, I hope you understand. If you understand, like and subscribe. Bye.